Damn, they have a greater acceleration than mine. I only have a constant acceleration of 18 meters per second.
Oh, we did it! We had an acceleration of 6 meters per second square! And he didn't! Even though we had less initial velocity of 4 meters per second, we won. Yeah. God, I just realized. We just saw this in school. We should literally make a problem out of this. We should make a physics problem out of this.
Said no one ever.
In calculus. I just realized I don't have one. But 3 marks in my link. You can blame me? Yeah!
One car moving with a constant velocity of 18 meters per second passes a second car initially moving at 4 meters per second, as it does the second one. The second car begins to accelerate at a rate of 6 meters per second squared.
Data. Car 1 is moving at a constant velocity of 18 meters per second. On car 2 is initial velocity is 4 meters per second, but it has an acceleration of 6 meters per second squared. Question 8. Write the position function of each car depending on time. First of all, we have to search for the general expression for position at time t. Well, our general formula is x belongs to t equals to position plus initial velocity at x times t plus acceleration times time squared over 2. We have to substitute car 1 and car 2 according to the data we have. For car 1, we only have the initial velocity, so the function will be x of t equals 80 times t. And for car 2, we have acceleration and initial velocity, so our function will be x that belongs to t equals 3 times t squared plus 4t. Question B. Calculate the derivative of the position function of the two cars using the limit definition of derivative. Derivative is the slope of the tangent line to a curve at a certain point. The formula for a derivative is the limit of h approaching 0 is equal of f belongs to x plus h minus f belongs to x over h. In this question, we found the derivative for the function of the car 1 and car 2. Question C. How long does it take the second car to catch the first car? Well, here we are looking for the time, and we have to find a real variable for time of both car 1 and 2. So we make an equality. Question D. How far did the cars travel during the time interval required for the second car to catch the first car? Here we use the position function for car 1 and car 2, and we substitute t with our answer from question C, and the result was 83.88 meters.
For question E, we want to know the velocity of the second car as it went past the first car. So we're going to use the formula final velocity square equals initial velocity square plus 2a times x. We only have to substitute it and we get the result of 31.97. For F, we want to know the average velocity for when the second car passed the first one. So we use the formula average velocity equals final velocity plus initial velocity over 2. So we only have to substitute values and we get 18.985 meters per second squared. Finally, for G, we only want to know how long will take the second car to reach 100 meters per second. Say for physics, we have the formula final velocity equals initial velocity plus acceleration times time. So we only substitute values and we get 16 seconds. And for calculus, we have the derivative. We only have to isolate t, which is time, and we get the same result, 16 seconds.
It was amazing all that we could get with this. I have just one more question. Who are these people? Damn it! You stole a car again! Jeez!
And math.